Hey guys, this is my Excel tutorial on performing calculations with formulas and functions. This is all about just making things a little bit easier. That's what Excel is all about, making things easier. So if it seems confusing, it's actually trying to make your life a little easier. So keep calm and Excel on. But we're going to go through just formulas you've probably never seen before, but that's okay because we're going to learn how to input those formulas into an Excel sheet, and then we're going to use formulas that are built in to Excel. They're called functions. So Excel functions to calculate numbers. And then we're also going to use what-if analysis and then check for errors in our formulas as well. So we're gonna use a little bit of math, but it's okay because Excel makes your life a lot easier when it comes to using math. Or at least I hope so. So this might be a little bit of a review. You might not be familiar with this example, how to calculate the area of a circle. So just a reminder, equation is area equals the constant 3.14. Pi is always 3.14. That number doesn't change. So that's easy. Also plus, like if we knew, so this is a number we have to gather. So we have to measure out, this is the radius, this is the halfway point. Okay, diameter would be a whole line through and see how long the circle is through the middle. But this is the halfway point, and then it's also to the exponential of 2. So radius squared, so the formula is area equals pi times the radius squared. So what that would look like in Excel with these numbers, so we have those numbers, we just have to know how to put it into an equation. So the first thing you do, and if this is new to you, I do have a video on how to do operations and just very simple like math equations. Just click on the link above. But if you're sort of familiar to this, just keep following along or come back if you have to check out the video. But anyway, so the formula would be, whatever we're doing an equation, you have to start with equal. It would be pi, so we're going to use that as a cell reference because that's not going to change. Pi is always 3.14. And then because we have to do something first where we get the exponential 2 of the radius, so we have to do that first. We have to put it in brackets. If you try to get to the equation, do that. Oh, I forgot my multiplication. Star, so press Shift 8. So it's pi times, I could type in 8, but I'll use that cell reference in case we change the radius number or the circle was actually bigger than we thought. To the exponential of 2, so to do exponential, you just do Shift 6 on your keyboard, and then to the exponential of 2, and then close the bracket. Okay, so we have pi times radius squared, and that's what it would look like in Excel in this example. Okay, so we press Enter, and we almost get this, so the area of the circle would almost be, if this was 8 feet, it would be 200 feet as a circle, the area of the circle. That's what the number would be. Okay, so hopefully that's just a good intro to what we're doing in this example, because we're going to use formulas that we're not familiar with. They're on the explanation of formulas worksheet. So here is all of them, and they can be a little bit confusing. That's okay, as long as we know how to put it into Excel. You'll probably never use these formulas in real life, but that's okay. We're going to set it up for someone who can collect data, but maybe not. They don't know how to input the formula in Excel. So we're going to do that. The first formula is we got to get the sample area. So the formula for that, and it's on your explanation of formulas worksheet, is the number of rows. So what basically happened is they have about an acre of cornfield, like they have a huge cornfield, but they just want to take a sample, so it's not that much work because that could take a long time. So we'll just take a small sample, 6 rows, and then try and figure out our numbers from that based on that small sample. So the area is 2 times. Now I've never seen this formula before, so this is new to me, but at least I know how to put it into Excel, so that's the point. So it's the number of rows, 2 times the number of rows, and all the numbers are collected for us, and if they wouldn't, then we can't really do this, but all the numbers are inputted, so that works for us. And then times B8, which is the width times the length. And then it's also divided by the constant, so how many square feet are in an acre, because you're trying to per acre. So you're dividing by how many square feet are in an acre, in 1 acre. And so that's a constant number that doesn't change. So just kind of like the pi example, that number doesn't change. And we'll press equal, and that is the correct number. Now we're going to take this, we don't want these ugly numbers, there's too many. We're going to round a little bit by going to decrease decimal size, and we're going to just decrease it to 2 decimal points. Okay, so the sample acre that you took is 0.2 of an acre. So that was our sample size, or sample area. Now we have to figure out the weight of the corn, because we want to see how much corn we collected, or how much we would collect if we did the whole acre. So, but we also have to take into consideration the moisture content, because the moisture can add to the weight, but it's not a true weight of how much corn we collected. So that formula, so let's say the farmer that we were working with measured it to be about 16.3, and then I'm going to put percent after 16.3%, and I'll take that down to 1 decimal. Okay, so if you were to put that as a number, and then changed it to a, just make sure you kind of do what I did, where I put the percent as I was typing the number, because it can get confusing. So, okay, so it's 16.3%, which would be 0.16 as a number, so 0.16, 163, but we put in percent, so that's okay. So the dry weight would be, it would have to do with the percent of this number. So to get that, the formula would be equal, so B13, use this as a reference, because if that number changes, then we don't have to redo this equation. The number will just adapt. So it's the weight times, again, you'll probably never have to know these actual equations, so 1 minus the percent. Okay, so 1 minus the percent, you get that number, and then multiply it by the weight to get a percentage, or to get how much you know, a better accurate number of the weight minus the moisture. Okay, so that's our number without, that's our dry weight. So taking into consideration that some of the weight comes from moisture, and then we'll just take it down to 0 decimal place. So yeah, that's the dry weight without the moisture. And then to get the market weight, we have a different equation, so it's just equal, a little bit similar to that one, but it's B15. So it's the dry weight divided by, and we have to put parentheses around this one part, 1 minus E8 standard corn moisture content. All right, so that's just kind of a standard number. And again, I don't really know what that formula is all about. It's my first time seeing it, but as long as I know I have to put it into Excel, that's fine. So, and if you wanted to, you could refer to the explanation of formulas. Actually, we're going to round that to the nearest one. Okay, so the problem with this one is that in our example, corn isn't really measured by weight. It's actually measured by how many bushels, or like one corn piece you have. So, so yeah, again, I'm not familiar with bushels, but that's how it's going to be measured. So how many bushels we can sell. And you see this number here is pounds of corn in a bushel. So now we can kind of estimate, based on the weight, how many sample bushels we have. So again, this is a formula. It's not just a number we're going to input, and that's important to know. So we're going to enter the formula to get our sample bushels, B16. So the market weight divided by how much a bushel typically weighs, to kind of get our how many bushels we had in our sample. And we had roughly about, we'll round it up. See, it's so close that you can't really go by decimals when it comes to a bushel. So yeah, round up to 34. We had roughly about 34 in our sample. So per acre, that would be, so now we have to involve this number here, the sample area, to estimate how much would be in 1 acre. And that would be equal B19. So how many sample bushels did you have? And then divided by the sample area that we took. Okay, because we're estimating, so you should have 34 per 1 acre, and then divide that by what we actually have. And we get about 100, we should have about 167, so we're going to actually round that as well. Actually, it's around 168 now that we round it, so we take away the decimals. And the total yield would be equal, so always remember to put equal when you're starting an equation. B20 times, so that would be bushels per acre times B4, total corn crop acres. Okay, so they have a total of 137, and we're getting the how many bushels per acre, so you times it by how much they actually, how large their land is, and it should come out to, around about 23,000. Now, to make that look a little bit nicer, to format it nicer, we can, whenever you have a big number like that, it's good to put a comma style in there. as well. Just make sure that, see what I did there? It went back to 2 decimal places, so I'm going to round down there. And because I had a previous formula in there, I was skipping ahead a little bit. So to get the total revenue, if we look up here in the formula bar, it's B21 times the price per bushel. So this is how many bushels we have, and then times how much they're worth per bushel, and that's how we get our how much that's worth, which is about $88,000. So, and you can also do, because that's a grand number, that's we can use accounting format. Okay, so I'm going to make that, because that's a dollar value. And now we're going to apply certain cell styles to let us know which numbers were input. So which ones do we manually input versus which ones are actually a formula. See how I click on the formula and then the number or the equation that we put in shows up? So we're going to make this a little nicer based on inputted numbers. So every number that we inputted, now I'm gonna do this really quickly. So I'm gonna click a bunch of numbers and press, or a bunch of cells, and at the same time by holding down the control key and then clicking where I need to. So B7, B8, that's the numbers we put in. See how there's no formula. B7 to B8, B13 to B14, E7 to, so all these were inputted numbers, even though these are constants. And yeah, that's it. These are all, everything else was calculated value. So if you go to your cell styles, it actually has one that's works for input numbers. So we want to use because we want to make sure that it's not it's just an input number. So not input, right here, not output. So these are numbers that are willing to change, and they don't have an equation. Okay, so we could change this, like if you took a different sample size, number of rows. These are all numbers that could change. This one, I somehow missed that one. Also one. And then this one has an equation. So there's also a format for the equation cell. So now I'm going to, every cell that we use in an equation, just make sure when on the formula bar there's actually an equation in there. To identify this is something we calculated. And to show that, there's actually a calculation format in the data model here. So it shows numbers that were calculated. Okay, so that you know these numbers could change based on your research or the measurements we took, and then these numbers would change following what we had based on kind of what we measured. So that's the difference between an input. This is the numbers we put in. These are numbers that we are actually using an equation to calculate. All right, and there's different formatting with both. Okay, so now we're going to use formulas that are sort of built into Excel already. So let me just show you an example here. The difference between count and count A. So these are two different functions in Excel already built in. Now the count function is really good at counting numbers. Let's say these are students here and these are their marks. If I wanted to count this, I would say equal count. So it's already a built-in, it'll count numbers in that range. So equal count, open bracket, and then I highlight the range. Or I could, if I knew I was going to add more numbers later, I could just highlight the column. But let's just highlight the range in this example. Okay, because I'm putting the totals under, so the chances of me adding more later, very slim. So count, and tells us we have 14 students, and that makes sense because we have 14 rows after this marked one, so that makes sense. Now, watch what happens when I try and do count for this. So if I'm trying to count the students by their student number, watch what happens here. It doesn't do it. So this means we need count A. Now, count will count numbers, but it's very limited to only numbers. Count A, on the other hand, will count, I don't know why it's not defined like this in the textbook, but I think A as anything. It'll literally count anything in the cell. And it'll skip something that's blank. But see these little hyphens here between the numbers? Simple count function won't actually count something like that. Or if we put an X to count something, but equal count A, so count A will literally count everything, anything. So think of A as anything. A stands for anything. Okay, so now that when we go highlight this range and then close the bracket, it should also say 14. Okay, so if you're counting numbers, count is fine. If you're counting anything else, words, letters, or symbols like that, count A will do count everything. Okay, so just to know the difference between count and count A. All right, so now we're going to go to our yield history. and we're going to get a count for this one. So we're going to use the same formula. Sorry, function. I just got to start saying function. Function is just an Excel formula that's already built in. So now we could highlight this range like we just did, or if you want to add some numbers later, let's say the years are going to keep continuing, so we don't want to put anything down here because we just want to keep counting the years, and we can just highlight column E, which would count everything that exists, and it's going to miss this blank one. And then close the bracket. That should give us 22. Alright, so now we're going to try something a little bit confusing with Excel, and you're going to use it a little bit later to do a little bit more tricky functions. We're going to do embed a function within another function. So we're going to use two at the same time. So we're going to use something, to get the average, we're going to embed the average number into the round function, which will basically just round it to whatever we want to. If you say 1 decimal place, 0 decimal place, or maybe 3 decimal places, the round function will let you do that. So we're going to type in round. So this will help us when we're doing embedded if functions later on. So round, and then open that bracket. So the numbers that we're going to need, we need the number, and then we also need, to do the round function, we need a number, and then we also need what you want to round it to, how many digits. So you see in the kind of the description here, you need a number, and then how many digits you want to round it to. So the number we're going to get is from the average. So we're going to type in average, and then we're going to do that cell range again. So we're going to get the average number from here. So we've closed out the average function. That's complete. But we also need to close out the round function. So we have to do comma and 0, and then close that bracket. So we need to see the round, we close out the average function, which is those 2 red brackets, and we also need to close out the round function as well. So we need to close out both. And then when we press enter, it's easily rounded to 170. Alright, so that's just how you mix 2 functions together. Now we're going to look for the smallest number. So I'm going to type in equal min, which would be the smallest number. So yeah, and then I'm going to do the same thing, get the E range, and the smallest number, 102, that was in 2005. So we had a bad year for corn, and then just max. So now we're going to look at the best year for corn by highlighting this range, and let's see what we got. 187. Can't even see that. So 2012 was a good year for corn for whatever reason. Now, okay, so let me explain median. This is relatively a small sample. Let's compare it to house sizes. So let's say you're sampling a street, and the houses are generally between $400,000 and $600,000 in worth. But then you have this neighbor who kind of demolished the old house they had and built like they had lots of money, they built a $4 million house on top of everything. So if you took the average of that big house would really kind of sway the numbers in its favor, and it would make the house value of that street seem a lot bigger than it actually is, based on that one kind of outlier in the data. Median would just take the middle numbers, so it's kind of less swayed by like really big numbers or small numbers, and it would just take the middle value, so you get a better accurate representation of how much the houses were actually worth. Sort of like this small sample here. So there's not a lot. If you have large numbers, average is fine. But with a small sample size, it's probably better to use median. And if you didn't know what that was, it's okay. You could type, what you could do is click the insert button and say, what do I want? Okay, so I want to type in the description what I want. So I want the middle number. So I want the middle number, not the average. I don't want the average. Middle, I don't want someone's middle name. I want the middle number. And then median just pops up, right? Median's the top one. You could also go mode, which is similar. But median is what we want. Okay, so just type in, and we want, so the range we want is actually there. So this is our function dialog box, and it's going to do it, it's a little bit friendlier than typing it in ourselves. Okay, so if you don't know what it is, you can also click on the insert function dialog box and just type in, kind of give a description what you want, and the right function should actually pop up. Alright, so now we're going to talk about a what-if analysis, and what that is it'll look at, it's an analysis of the variables in an equation and what would be the consequences if they change. So for this example, we're going to see what it would be like. Maybe we can increase the size of our farm to get a higher revenue. Let's say we want to make $100,000 from our corn sales. So let's see how these numbers are related and see what we can change. And then, so what if analysis involves an equation, and we have to change some variables to get a different solution, or a different answer. So we're going to try and see what we can change to get this to 100,000. So I look back, this is, to get this number is equal B21 to E10. So we can't really change the price per bushel. That's just a market price. All right, we can't really raise that. That's not on, that's not up to us. So we can't change that at all. And the total yield bushels, well, that's kind of limited too, because you can only sell so much in a given space. So if we go to this this B21, we see something that we actually can change, which is the size of our farm. Maybe there's a little bit more room we can, or maybe room for corn. So we can change the number of acres that we sell corn from, because this is kind of fixed, right? Once we get this number from the space we have, you can't really do too much about that. So let's see. So there's two ways to do a what if analysis. You can just do simple trial and error. You can try to put a different number in here. So if we put in a higher number, we should get close to the 100,000. So let's increase our farm size to 150 acres and see what would happen. Okay, so we got close. We're at 96,000 now. Let's try and up that to 175. Okay, well that's way over. And you know what? Maybe you're thinking we could afford 175. Let's just go for 113,000. Sure, but let's say, you know what, that's being greedy. Let's get right to 100,000. We don't have a lot of space, so we can't go all the way to 175. There's a more precise way to do this. So, you could keep playing around with it until you get to the number you want, or you could be a little bit more precise. So we'll change it back to 137, and then I'm just going to deselect a cell because we have to put in different cells anyway. So in the data tab, there's this, in the forecast group, we see the what if analysis. Now, if this is new to you and you want to see how else, or like a different situation you can use, I had a fun one with my buddy Sean, and we did what if analysis for running times. So if you want to check that out, click the link above. But or you could also just follow along with this example. Okay, so we'll go to the what if analysis. Remember, this is in the data tab, and then we will go to goal seek. So I'll kind of explain this little dialog box to help us get our number. So the set cell, that's the one you want to change. So this is, sorry, not manually change. This is kind of your solution cell, the one, you know, with the consequence. So we want to take, from our variables, we want our variables to change so that it turns to 100,000. That's your set cell. Okay, that's kind of like what you want your goal to be. And the value is actually the actual number that you want your goal to be. So our actual number was 100,000, so we'll type that in here. Okay, so we want this cell to turn into 100,000 by changing the total acres that we have. So that's this cell. Okay, so this will change to give us exactly what we need for this to be 100,000. And then we press OK. We have all the numbers. If you had an error, you might have just clicked the wrong number or the wrong cell. That's okay. You have to redo it, so press OK. So now we're at 100,000. We reached our goal, and we would need 155 acres to get there, okay, to reach our goal. So that's how you should use the what if analysis, and more specifically goal seek within what if analysis. So I hope that was helpful for you. I will be uploading the second part to this module, but while you're waiting for that, you can check out some of the videos that I mentioned earlier that will help you kind of understand module 3.1. And that is my operations and functions video, and as well as my goal seek video. And you can also click on my face right here to subscribe to my channel. Thanks for watching. We'll see you next time.